Hello everyone, welcome back to Educquiz for exercise 3 on partial fractions, which goes by 3x plus 5 divided by x minus 2 into 2x squared plus 3. So we have to change that to partial fraction. Let's copy back the question. Okay, so when we see this, before turning to partial fraction, we have to check for the first two requirements. The first one is the numerator's degree less than the denominator's degree? What is the numerator's degree here? It is x. The degree, let's remember, is the power, the highest power of x, that's the degree. So the degree of the numerator is 1. The highest power of x here is 1. What is the degree of the denominator here? We can see that we have, in the first bracket, we have, in the second bracket, or in one of the brackets, we have 2. In the other bracket, we have 1. So we add the x's, because when you open the bracket, they are normally going to multiply and form an x cube somewhere. So the degree of the denominator here is 3. So the first step is actually fulfilled. The degree of the denominator is bigger than that of the numerator. So the second one is to check if the denominator is factorized. Here we can see that the denominator is actually factorized. So we can move on, we can proceed. When the first two are done, then we start solving. We put it in the partial fraction form and start solving. So how do we put it in partial fraction form? This will be equal to a. This is the first type of partial fraction that we saw. It is partial fraction with linear factors at the denominator. So it is a on x minus 2. That is a linear factor at the denominator. You can remove the bracket, it's the same thing. Plus b on I can see here that this is quadratic equation. How do I know it's a quadratic equation? I can see square here. Because of this 2, it is not linear, it is quadratic. Is this a factorable quadratic equation? No, we cannot factorize it. On the previous exercise, if you do not view exercise 2, go back and view exercise 2. You will see how to know that a quadratic expression is not factorable. So I can see that this is not a factorable quadratic equation. So when I deal with non-factorable quadratic equations, I look at the third type. The third type, it was written there. The third type of partial fraction is partial fractions with non-factorable quadratic equations at the denominator. So here is it here. In this case, I put bx plus c. Bx plus c divided by 2x squared plus 3. So that is it in my partial fraction. I took too much space. I think I can reduce it a bit. Not that much different, but at least it's better. So what do I do next? I find my LCM. The LCM here will be just the product of these two. So I'll write it x plus 2, x minus 2, into 2x squared plus 3. When I find my LCM, I do this divided by this times a. So it is a into, when I do this divided by this x minus 2 will cancel x minus 2. I'll be left with 2x squared plus 3. So I have 2x squared plus 3. Now, plus I copy this with my bracket. I never forget the bracket, bx plus c into, when I do this divided by this is going to cancel this. 2x squared plus 3 is going to cancel with 2x squared plus 3. I'll be left with just x minus 2. I have it that way. That will be equal to, this didn't change. I can recopy it, 3x plus 5 divided by x minus 2 into 2x squared plus 3. What do I do next? I do the cross multiplication as you all know. When I cross multiply, this is going to come here and this is going to come here. I will see that this that will be here will cancel with this that will be here because it is actually the same thing. So when you cross multiply, they're going to cancel. So when you have it like that, when you cancel it, you will see that just the numerators on both sides are going to be left. So I'll recopy the numerators. I have 3x plus 5 is equal to a into 3 plus bx plus c into x minus 2. So when I have it like this, I can either expand and compare the coefficients or let. I've taught already how to expand and compare coefficients, and I've also taught how to let. So here I'm going to find a, I'm going to use the cover-up method to find it fast. How do I use the cover-up method? I look at a. I can use the cover-up method just on a because a does not have a quadratic. If there was a square here, I would not have been able to use a. If there was a square anywhere here, even if it was here, I can't use it. So when there is no square, that's when you are sure you are using it here. If there was a square here, actually you can use it and you work just for this one. If there was a square, it means that there is a part where there is a plus b somewhere that is like this, x plus 2. In that case, you will not be able to use it on this one if there was a square here. If you have this plus something like a on x plus 2 all squared, if you use the cover-up method, it will work just for this. It will not work for this. So before using the cover-up method, make sure that there's no expression like this that is squared somewhere. If there's an expression like this that is squared somewhere, it will work just for that part that is squared. But since here in this case, it is just this. There is not this same thing that is squared anywhere else. It's just this and this. I can use my cover-up method on that. So using cover-up method here, which value of x will I put here to make this to be 0? So you look at a, you see under a, you see x minus 2. Which value of x will I put on x minus 2 to have 0? If you are, you can say that it's 2. But if you don't know, the safest way to solve, you put x minus 3 equated to 0. What will be the value of x? You can bring this 2 here and you have positive 2. You can say that 2 minus 2 is 0. So what do? I cover up x minus 2. And I replace my 2 everywhere else. So when I replace my 2 up, I'm going to have 3 times 2. 6. 6 plus 5, 11. Okay, 2 squared is 4. 4 times 2 is 8. 8 plus 3 is 11. I was already afraid when seeing the number of 11. I was like, I'm going to have 11 on 7, something like that. Well, that is it. So 11 on 11 is 1. So using the cover method, you can see that a is 1. But if you want to do the cover-up method, you have to write in your book, using cover-up method, you can see that a is 1. Because there is no solving actually when doing the cover-up method. You don't do any kind of solving. So you can write it like that. But it is recognized that as a way of solving. So the lecturer, your teacher will not put you wrong if you state that you used cover-up method. So a is equal to 1. Or by default, you can solve physically. You can solve it physically. You can replace 2 here. You write it like this: 3 into 2 plus 5 all over. You write a equal to like this: 3 into 2 plus 5 all over. You cancel this. You put 2 here. 2 into 2 squared plus 3. You see there is 11 on 11 is equal to 1. You write like this. You have your a as 1. This will be a better option when you are solving the cover-up method. So you have your a as 1. So you should better do this and find your a as 1. So to find b and c, I will let values. I choose to let because I want let. I like it. If you want to expand and compare, you can also do it. It will not be that much different from it. It will not even be longer. You can still do it because I just like letting I just do it. So I will let what values of x will I let here? I first check here. Is there any value of x that I can put here and have 0 here? I said it's not possible. I have something that is square and plus anything, something else. Something that is square means the value must be positive. You cannot add something positive to a positive answer. I have 0. It's not possible. So here, I do not have anything. You come here. Is there any value of x that I can put here that I will have 0? Yes, I see that if I put 2 minus 2 give me 0. If I don't know, if I doubt, I can do x minus 2 equals to 0. X will be equal to 2 when it will cross the equal to sign. So my first value is going to be 2. What else will I use? Because I need 2 others. I need 2 values because I already have A. The next unknowns are B and C. So I need 2. What else will I use? I think that when I use 0, 0 is going to cancel this B. And 0 is going to cancel this B. So it's going to reduce my equation. So I can use 0. So those are the 2 values of x that I will use. So firstly, I will let x to be equal to 2. Letting x to be equal to 2, I will have here down. I'll put x here. I have 6 plus 5 is 11. 11 is equal to 11a. So it's 11. But when I put 2 here, this already has a new already that a is 1. So I cannot actually use that to find another thing. So I have to let something else. Because using the cover up method is like 2 was already used here. Because I let 2 and I put it here. Using my cover up method, 2 was already used. So I have to find something else to use. 0, I've already put 0. I can use 1. 1 is also something that is simple to use. Multiplication, you just add 1. And addition, you just add 1. Multiplication is the same thing. So I'll use 1. So I'll let x to be. Well, I'll let x to be 0 first. I'll let x to be 0. When I let x to be 0, I can see that I replace 0 here. I'll have 5 is equal to a into 3 because this is 0. 0 squared is 0. 0 times 2 is 0. So I have 3 left in the bracket. 3 is left. That 3 multiply a plus. I write this bracket. I see that b times 0 is 0. I write my c inside. And I write 0 minus 2 is minus 2. I have a is 1. So I can see that 5 is equal to 3 minus 2c. When I bring this 3 there, I have 5 minus 2 minus 3, which will give me 2 is equal to minus 2c. Which implies when I divide all through by minus 2, I have c as minus 1. So I have my value of a and c. A is 1, c is minus 1. I can now find the value of e. So I'll let x to be just 0 and 2. So I'll let x to be 1. Letting x to be 1. As I let here, will be better to write letting x to be 1. Letting x to be 1. Because that's actually what you are doing that you're writing. But if you write let x to be 1, it's fine. So letting x to be 1, I replace here 1. 3 times 1 is 3. 3 plus 5 is 8. 8 is equal to x is 1. A into, but a is already 1. So it will just be, well, let me just write it. To not confuse you, I'll write this step by step. 2 times 1 squared is 2 plus 3 plus b times 1 is b. I've let x to be 1, so everywhere I see x, I put 1. B times 1 is b plus c into 1 minus 2 is minus 1. If you doubt what 1 minus 2 is, use a calculator. Don't be ashamed. Even if it is 1 plus 1 in the exam hall, use a calculator. That is even what I was doing. Even though I know the answer, I think I know the answer. I've done so many errors on it, which I was sure that I knew the answer. That now I almost always use the calculator. So use a calculator if you're not sure. Even if you are sure, check twice. Because when you do errors, you're always sure that it is correct. Then you notice that you have done it. So even when you're sure, use your calculator and check twice. That is why you have a calculator. So you have A at 1 and C at -1. So A and C already you have them already. You have to find B. So I'll first simplify this. I have 8 is equal to A into 5, which is 5A. 5 times 1 is 5. I can put 5A plus B minus 1. Because C is -1. So I place the -1 here, all into -1. So I have 8 is equals to 5 because A is 1 plus B times -1. I open this bracket, I have B times -1 is minus B. -1 times -1 is +1. So I'll make this B to cross here. B will become positive. I'll make this 8 -8. I could still put -8 before 5 or -8 after 5. Same thing. I put my +1. So I have B is equals to 5 plus 1, 6. 6 minus 8 minus 2. So I found my value. What do I do now? I just repeat them here. So I see that this will be equal to, I put my final answer here. I'll have A is 1. So it is 1 on x minus 2 plus B is -2. -2x plus C is -1. So it's -1 on 2x squared plus 3. If I write it like this, is correct. But if you put a sign, then you put a negative sign, it's not. If you point this on a calculator, the calculator will not understand. The calculator will tell you that it's a syntax error somewhere. Or maybe not, depending on the calculator. There's some calculators that will understand that plus minus means minus. But for it to be more beautiful, more aesthetic, you can see that you have minus and minus here. You can just put your minus one time here, then put plus. Like this. You see that this minus multiply this and this. And it's exactly the same, but more beautiful. So that is the final answer. Hope you had it correct when you were solving. So thank you for watching the video and hope you keep on following the videos on Educlynk. Keep learning on Educquiz.